Hello everyone, and thank you first of all for the invitation. My name is Antonio Tirri, and I'm a service innovation engineer in ETRA. Before starting, just a few words regarding my company. L'ETA is the competence center of the Unipol Group, focusing on data science and computer science topics. So, in particular, my group works on projects aimed to analyze the impact of natural events on the insurance business. So, we are designing innovative solutions for all our stakeholders. I'm going to be speaking to you today about the first project of the IFAB Foundation, as mentioned before, that is the European Extreme Events Climate Index. So I'd like to start discussing the primary need behind the project. As you probably know, in recent times, we observed an increase in the frequency and intensity of extreme events with a significant impact on both quality of life and also economy. Even from our perspective, that is an insurer perspective, claims that are caused by natural events are becoming more and more relevant. And this results in an emerging need for tools that are designed to support the implementation of strategies in the climate domain. So, as you can imagine, this topic is not totally new, and in fact, some products on this type already exist on the market and in scientific literature. For example, I can mention the Actuarial Climate Index that is developed by North American actuarial institutions. But in this project, we were inspired by the Actuarial Climate Index and in general by the state of the art. Then we implemented a set of improvements to create a tool with data that is available for Europe and worldwide. So here the result is the design and the implementation of the European Extreme Events Climate Index. So let's see the reasons behind the choice of the name. We used European not only because the project is made in Europe, but mainly because we based the index on the data released by European programs and institutions. Then we chose extreme events because the index describes well the occurrence of the most dangerous events that are the extremes. Then we use climate because you can use the European Extreme Events Climate Index or E3CI to describe climatic trends, and index because we needed a simple tool that could be easily processed and integrated into our existing processes. So IFAB, that is the International Foundation Big Data and Artificial Intelligence for Human Development, is the sponsor of this project. And as mentioned before, IFAB has the mandate to promote cooperation between public and private sectors in the field of innovative technologies. And in this sense, the index we created perfectly matches the topic. Then we have the Euro-Mediterranean Center on Climate Change that is here represented by Guido, Rianna, and CMCC is a reference point in Europe for climate change studies and assumes the role in this project of scientific partner. And finally, the third participant is L'ETA, my company, acting as technical and insurance partner. So in the slides, I reported 40 concepts that are related to the E3CI. The first one regards the input data. We calculate the index using the fifth generation of reanalysis data that is released by the ACMWF, the European Center of Medium Weather Forecast, as part of the Copernicus Climate Change Services. And the strength of this choice is that the data is available at global level with a delay of only 5 days. Then another important thing to say is that the index has multiple components and it can be considered as sort of an ensemble of indices. And at the moment, we have 5 components, each of which describes a specific atmospheric condition. We have precipitations, we have heat and cold stress, drought, and intense wind. Then it is also possible to calculate a summary index using a combination of the different components. We are releasing the index with monthly updates, and each value describes the anomaly of the current month with respect to a reference value that we call the baseline. And then regarding the spatial aggregation, at the moment the E3CI is published by country in Europe, but there is the possibility to perform different kinds of spatial aggregation. And moreover, we have in plan to extend the index over other countries in the world. The index can be used in different kinds and different types of use cases, and here I reported a short list of examples. It's important to say that each use case exploits either the general index or a combination of the different components. A first use case regards the insurance business, that is our field, my field, and is the improvement of budgeting and risk management activities. For example, the index is useful to forecast the impact of future claims that are caused by extreme natural events. Another one is the possibility to link innovative financial instruments to the trend of the index. But the E3CI could also be a clause of an insurance treaty or a clause of a parametric insurance policy. Since the index provides an objective measure to monitor climate trends, it is possible to use the E3CI in educational applications to raise awareness about climate change or to support public institutions in implementing sustainable development policies. Okay, I'd like to close this brief introduction on the E3CI with two references to explore the index. The first one is the IFAB website at the ifabfoundation.org/E3CI. And here you can find a general description of the index together with its components, the engineering guide, that is the reference document for the project, and visualization dashboard that allows the navigation of the index information. And as you can see in this slide, I have reported a picture of that dashboard. For example, here the figure shows the general version of the index in Italy. And here you can see a peak in October 2018, yes, when we observed the Vaia storm in the northern part of Italy. Then, on the other hand, expert users can download the E3CI data from the CMCC data claim platform at e3ci.dataclaim.org. Sorry. Okay, so the slides close this short introduction to on the E3CI. Again, thank you for your attention. And now I leave my reference for any further information. And now I leave the floor to Guido from CMCC for some scientific insights on the index. So thank you very much.
Okay, thank you all. Thank you, Antonio, for your nice presentation about the relevance of the index for financial insurance matters. Now I'd like to provide a few details about the scientific background of the components. As said before, we have we have 5 components for each stress, called the stress, extreme precipitation, drought, and extreme wind. For each component, we have associated the climate indicators, but now I would like to stress insights about climate indicators. Climate indicators have only a limited information content compared to more time resource consuming physically based modeling, but they represent a consolidated way to return information about the frequency and severity of weather-induced hazards. So, climate indicators are usually used for moderately rare events, while for rare events, more complex statistical approaches are required, for example, extreme value analysis. Okay, selecting an indicator represents a trade-off in order to maximize the information content. For example, for hydrodynamic hazard, the time of reference spans from a few minutes, for example, for urban flooding, up to several days for the largest river basins. So when we select a time of interest, we are able to adequately reproduce some dynamics, but we fail to reproducing other ones. For our climate indicators, as said before by Antonio, we started from the American and Australian climate indicators experience, but taking into account also European more recent experiences, as an example, European Environmental Agency indicators. Okay, A few words again about the input dataset. It is the fifth generation of SENWF reanalysis, ERA 5. It has a global coverage with an horizontal resolution of about 31 kilometers, with data starting since the 50s up to now, while the latency of only 5 days permit a prompt update of the components and then of the indicators. Nevertheless, it is freely available by using the climate data store included in Copernicus Climate Change Service. Okay, which are the main stages when we use a computing a component and then indicators? First of all, the identification of a significant threshold for detecting extreme events. After, the standardization over the reference period. Finally, the computation in operational mode month by month. The standardization is a key process. Why? Because it makes comparable different metrics, different dynamics, and in a way, it limits also the influence of systematic biases that can affect, for example, input data sets. So, brief details about the computation of the indicators. It a code. For each stress, we consider month by month the number of days for which a maximum temperature exceeds the 95th percentile of the corresponding temperature over a moving window of 5 days. At the same time, for cold stress, month by month, we consider the number of days for which minimum temperature is below the 50th percentile of the corresponding temperature. Both indicators, but all the 5 indicators, are standardized over the reference period 1981, 20, and 10. Wet and dry dynamics. For extreme precipitation, we consider the cumulative value of precipitation exceeding the 95th percentile of the daily values, while for drought, we use a more consolidated approach, the standardized precipitation index as suggested by McKee and colleagues. The reference time span in this case is 3 months. Again, for both, the reference time span for standardization is 1981, 20, and 10. Finally, again, a literature approach for extreme wind. We use the local loss index where the indicator is computed as the ratio between the maximum wind daily value and the 95th percentile of a maximum wind daily speed. So these are the indicators, but now we can provide a few details, few examples using as test case Italy. So we are now displaying, for example, the data for each stress all over the Italian country. But as said before, the data are available for each country up to now over Europe. So in bold line, you can see the latest 10 years not included in the reference time span. The general rule is then the higher the value, the larger the expected hazard and then the impacts. Furthermore, we consider the monthly value exceeding 1 or the location of the top 5 values decade by decade. For each stress dynamics, an increasing trend is clearly visible with the 42 events in the latest 10 years, and some events also included the relevant catalog for empirical damages, as for example, MDAT catalog, for example, for the summer 2003 on the summer 2020 and 18. Cold stress. Yes?
I'm going to ask you to bring us home.
Okay.
Thank you.
Okay, for cold stress, we have opposite trend with only 4 events in the latest 10 years, also included in the MDAT catalog. For extreme precipitation, we have increasing trends with 15 events in the latest 10 years, and some events included in the catalog of Copernicus for emergency management services, so very relevant at the country level, affecting North, Central, and Southern Italy. Again, for drought, we have recognized as particularly dry the spring 2020. And so for wind, as said before by Antonio, we have the largest value for October 20 and 18, where the northeastern of Italy was affected by the Rianna storm with the huge damages for the forest heritage. So Not by chance, the October 2018 is the only value exceeding 1 in the aggregated value. So for the consequent characterization of heavy precipitation and extreme winds. As said before by Antonio, the data can be downloaded by using the data client platform or can be visualized by using HiPub platform. Few words about next stages. We are thinking of adding some other components for forest fires, for hails, but overall we are trying to use the same approach also for climate reactions, then not only for back analysis of past events, but for understanding future variation, future evolution using climate reaction in neurocortex ensemble. Finally, for long term, our main ambition is then to shift from the hazard to the risk, so including data also about exposures and vulnerabilities. Thank you for your attention. In the slides, my contact and also colleagues in CMCC working on the index. Thank you.